Okay, this video we're going to be talking about polynomials again, linear factors, and also zeros, and then we're going to be looking at graphs and matching them with their infinity signs again. So if I say to factor this, first off we look to see if there's a GCF. There is. The GCF is x, so we're going to go ahead and divide that x out, and it's going to go in the front. X cubed divided by x is x squared. X squared divided by x is x. And then my x's cancel on the back end. Then we see if we can factor. So what multiplies to get me negative 15 adds to get me negative 2. That is negative 5 and 3. So I'm going to get x times my GCF, x minus 5, x plus 3. So we're going to be using factoring again to find my zeros. So then we'll do ZPP. And then sometimes we'll go the opposite direction. I'll give you the zeros, and then you're going to have to figure out what this standard form equation is. So if I say find the zeros of this, I want to find where it crosses my x-axis. Well, if I'm trying to find the numbers that represent the x-axis, that means my y value will always be 0. So we're going to take y out and put 0 in its place. And then, since it's already factored, all I have to do is ZPP. So x plus 2 equals 0, x minus 1 equals 0, x minus 3 equals 0. So I add 3 here to get x equals 3. I add 1 here, so x equals 1, and I subtract 2, so x equals negative 2. So my zeros are 3, 1, and negative 2. Okay, if I'm finding the zeros of this, I take my y and I make it a 0. And then I do ZPP. I set this equal to 0. I set this equal to 0. And I set this equal to 0. So I add 3 to both sides to get x equals 3. I subtract 5 to get x equals negative 5. So my zeros this time are 0, 3, and negative 5. So if I graph that, that's where it would cross my x-axis at. The factor theorem. So the expression x minus a is a factor of a polynomial if and only if the value a is a 0 of the related polynomial function. Okay, so what is the cubic polynomial function in standard form with the zeros negative 2, 2, and 3? So whenever we're finding the zeros, so if I go back, my zeros were always the opposite, let's change colors here, of what was actually in my parentheses. So this was a negative 3 in my parentheses, but when it came out and found my 0, it was a positive 3. So if I go the opposite direction and I'm given this and I have to put it in the parentheses, I have to make sure I use the opposite sign. So this first set, x minus 2, when I put it in my parentheses, I need x plus 2. Then my next one is a positive 2, so when I put it in my parentheses, I need to put it in as a negative 2. And my last one is a positive 3, so when I put it in my parentheses, I need a minus 3. And then I need this in standard form, so I need it all the way foiled out. So I'm going to take my first set, and I'm going to do this one here. Okay, I know since it's a positive 2 and a negative 2 that my center is going to cancel, so this will be the easiest one to start with foiling. So my f stands for first, so x times x is x squared. O stands for outer, so x times negative 2 is negative 2x. I stands for inner, so 2 times x is 2x. And L stands for last, so 2 times negative 2, which is negative 4. And I still have this x minus 3 because I only foiled out the first set. Let's go ahead and combine our like terms. So I have x squared, these cancel, so it's now minus 4. And then x minus 3. Now I need to FOIL this last set. So f stands for first, so x squared times x gets me x cubed. O stands for outer, so x squared times negative 3 is negative 3x squared. I stands for inner, so negative 4 times x is negative 4x. And L stands for last, so negative 4 times negative 3 is positive 12. So this is my equation in standard form given the zeros. And if you look, I gave you 3 zeros, and my highest exponent, or my degree, is a 3, which means I should have 3 answers, or 3 zeros. Okay, so this time I have negative 2, 2, and 3. So first off, we're going to write all of them. So a negative 2, we make sure we put it as a plus 2. We have 2 of those. Then we also have a minus 2 because I have a positive 2. And then a positive 3, we put it in as a -3. So like the last one, I'm going to match these ones because they'll be easier to do first because my inside will cancel. So if I FOIL it, we get the same as what we did last time. So we should get x squared. My centers will cancel, -4. Okay, and now we can choose either set. It doesn't matter what we choose. Technically, from the beginning, you could choose any set. There's just going to be sets that are going to be a lot harder to do than others. So now if I pick this set, F stands for first, so x times x squared is x cubed. O stands for outer, so x times -4 is -4x. I stands for inner, so 2 times x squared is 2x squared. And L stands for last, so 2 times -4 is -8. And we still have this x minus 3 on the back end. Okay, so now we need to distribute this guy in. So we're going to get x cubed times x is x to the 4th. X times -4x is -4x squared. X times 2x squared is 2x cubed. And then x times -8 is -8x. Now we need to distribute this -3 in. So -3 times x squared is x cubed is -3x cubed. -3 times 4x is a positive 12x. -3 times 2x squared is a -6x squared. And -3 times -8 is a positive 24. Now we need to combine all of our like terms. So it looks like I only have one x to the 4th, so I can just write that one. My x cubes would be next if I'm writing it in standard form. So I have positive 2x cubed minus 3x cubed, so that is a -x cubed. My next step is my x squared, so I have a -4x squared and a -6x squared, so that together gets me -10x squared. Then I do my x's, so -8x plus 12x, which is 4x, and then just my number, 24. At the end. So that is what it is in standard form. I gave you 4 answers, so my highest exponent or my degree should be 4, which it is. Okay, multiple zeros. G of x, so if I have this equation, g of x is the same thing as y, of x plus 2 squared times x minus 2 times x minus 3. The repeated linear factor of x plus 2 is a multiple zero. So I'm going to have -2. If I did ZPP, I would have -2 pop out twice because it tells me that there's 2 of these. So if I rewrote this as x plus 2 times x plus 2 times x minus 2 times x minus 3, it means we'd have a multiple zero. This repeats. So if we have multiple zeros, we also have multiplicities. So a multiplicity is how many times it repeats. So in this situation, -2, the zero, -2 would repeat twice. That is my multiplicity. How many times my zero repeats. Okay, so find the multiplicity of the zero. So first off, we need to factor it. So is there a GCF? It doesn't look like there is one. My next step, there is one, x squared. Goes to the front side. X to the 4th divided by x squared is x squared. X cubed divided by x squared is x. And then my x squareds cancel on the back end. And if we're trying to find the zeros to figure out how many multiplicities, we're going to set it equal to 0. So if we factored, what multiplies to get me -8, adds to get me -2, is going to be -4 and positive 2. So if I do ZPP, I got x squared equals 0. I got x minus 4 equals 0. I have x plus 2 equals 0. In this, I should have 4 answers. So if I add 4 for this, I get x equals 4. If I subtract 2, I get x is equal to -2. Opposite of squaring is square rooting. So x is equal to 0. But here's the thing. If I'm supposed to have 4 answers, here's 1, here's 2, this squared normally gives me a positive and negative side. So I need to have 2 answers. So this is actually x is equal to 2 twice. So I have at 0 a multiplicity of 2 because of that squared. So there are my 4 answers. Okay, so now if we wanted to graph this, we could plug it into our graphing calculator and show all those spots that cross the x-axis. Okay, another way to graph this is, let's mark all of the spots that it crosses my x-axis, so -2, negative 2. Let's change colors here. Negative 2, we got 0, and then we also have 4. And let's kind of figure out the direction of which way our graph is going. So right now, if I look, I could do my little shortcut to see if A is positive and negative. So right now A is positive and my N is even. Even means even Steven, so it's either going up, up, or down, down. Since it is positive, we know it's going up, up, so the direction of my arrow should be going up, up in the end. But I need to figure out where it's going in between all of it. So let's go ahead and pick a point. Let's pick negative 1. Okay, we're going to plug negative 1 in and see where my graph hits out. So if I do a little t-chart and plug negative 1 in, I plug negative 1 into this equation with parentheses. So I'm going to type that into my calculator. Make sure you have parentheses, and I'm going to tell you what you get out. Okay, you're going to get negative 6. So if I graphed it, I go left 1, down 6. Now I need to figure out what's happening on the right side. So let's go ahead and plug in 1, because I don't have a point sitting on 1 yet. So we're going to plug 1 into my equation with parentheses and see what we get. And I get negative 9. So I go right 1 and I'd go down 9, so it sits somewhere down here. So if I were to connect these points, it goes down, and then my having to connect all my points, it would go back up. So you can see that this x squared at x equals 0 actually makes a parabola at 0, 0. Okay, you could check this graph by graphing it on your calculator to get a little bit more mathematically so that you don't have to plug all these in. You can go to the table feature and check that out. But otherwise you could do it mathematically, plug in to figure out where it's going, or you can just guesstimate based on the graph on your graphing calculator to kind of show what it looks like. Okay, relative maximum and minimum. When we're talking about maximum and minimums, we always talk about the highest point or lowest point. Okay, the relative maximum or minimums are going to be where it changes direction. So maximum is going to be any times it changes direction and makes a maximum point. Minimum is where it changes direction and makes a minimum point. Okay, so this is going to be my relative maximum, and this is going to be my relative minimum. The difference between a relative max and a maximum is that we could have multiple relative maximums. It's just the changes of direction on your graph that would create a high point. Okay, minimums would be technically your lowest point. A relative minimum is anytime it changes direction and creates a low point. So you could have multiple relative minimums too. Okay, find the zeros and state the multiplicity of the zero. Okay, so this cubed means it's written out 3 times. So 1, 2, 3. If we're finding the zeros, that means I change my y to 0, so I can use my ZPP to find my zeros, or where it crosses my x-axis. So when I do ZPP, since all of these are the same, I'm going to go ahead and just do one of them. So I subtract 3, so x is equal to negative 3. So at negative 3, there's a multiplicity. If I can write multiplicity of, how many times do I see it happen? 1, 2, 3. So at negative 3, there's a multiplicity of 3. My next one here, I got y equals x times x minus 1 times, we got to write it out 3 times. So if I do my ZPP, I got to set all of these equal to 0 to find the zeros. So I would set this equal to 0. Since all these are the same, I'm just going to do one of them. So I already got x equals 0. We have to add 1 for this. So I get x equals 1. So at 1, okay, there's a multiplicity this time of 1, 2, 3 again. So however many times you see it happen. So at 1, there's a multiplicity of 3. My next one here, I got a factor. So first off, we see if there's a GCF. The GCF is x. So we're going to divide that x out. So 0 equals x times 2x squared plus x minus 1. Now we need to, we could do ZPP or we could keep factoring the inside. If I did ZPP, I would get x is equal to 0 and 2x squared plus x minus 1 equals 0, in which case we're going to have to factor it again. So we'll send this 2 back. 2. So it multiplies to get me negative 2, adds to get me 1. That is 2 and negative 1. So I'm going to get x plus 2, x minus 1. Well, I sent a 2 back, so I need to make sure I divide by 2. If I can simplify, I do. So this becomes x plus 1 and 2x minus 1. So then I set those equal to 0, so I'd get negative 1 and positive 1/2. So I do not have a multiplicity with this, because none of them repeat. I have 0, I have 1/2, and I have negative 1, and none of them repeat, so there is not a multiplicity. Okay. Relative maximum and relative minimum. So maximum, it's whenever we see a change of direction and it creates a high point. So this one right here. So we're going to kind of guesstimate it where it's at. You'll be able to, on test or quizzes, see the actual spot. So I'm going to say this is like negative, remember you always do the x value first, so let's say negative 0.3. And then my y value it hits at is about 2.1, we're going to say. Now we need to check our minimum, so anytime it changes direction and creates a low point, so that looks like it's sitting at my x value, 1.5, and then my y value, it looks like it's sitting at negative 0.5. So you always do the x first and then your y, so left or right and then up or down. Okay, so it looks like if we want to do our infinities, it's going to negative infinity on the left side and positive infinity on the right side. So it is going downward, then upward. This is going to help me figure out what my sign of my leading coefficient is and what the degree of the leading coefficient is. Okay, so right now, if it's going opposite, we know something needs to be odd. We just need to remember which one's which. So going back, we have y equals axn. N represents even or odd, and a represented positive or negative. Okay, degree of my leading coefficient, remember, means the exponent. So this is wondering if it's even or odd. And this, sign of leading coefficient, I want to know if my sign's positive or negative. So remember, my positive negative always talked about my back end arrow. So my back end arrow right now is going up, so we know that this A, whatever it is going to be positive. And then it says the degree, so I want to know my exponent. Well, if I'm going opposite directions, we know that's odd. So I know my exponent, or my degree, is going to be odd. The next question is to state the 0, so where it crosses my x-axis. So it's crossing at -1, it's crossing at 1, and it's also crossing at 2. If you wanted to write them as points, you would write them as 0, -1, 0, 1, and 0, 2. Okay, so relative max and min. So it looks like we have a maximum right there at 1, 0. We got a minimum right here. We're going to say that's about, we'll say 2.3. And then -1 for the y value. We're going to do our infinity signs because they're easier normally. So it goes from negative infinity, so it goes down, and then it goes up again. So positive infinity. My zeros are pretty easy. Crosses my x-axis at 1 and 3. And now we're going to do the sign of the leading coefficient and degree. So right now they're going opposite directions, so I know it's odd. And I know my back end arrow is going upward, so it needs to be positive. Okay, so when we're talking about degree, we talk about the exponent. The exponent, we talk about even or odd. So this is going to be the odd. Sign of leading coefficient means the positive or negative. So that is going to be positive. Okay, this one. Boop. Looks like we are going up and up, so we are both going to positive infinity for both of them. My zeros are -1, crosses at 0 right there. Don't forget about that one. It looks like it crosses at 1 and also crosses at 2. My maximum, so a high point, is going to be right here, so we could write 0.5 for the x, 0.5 for the y. It looks like in this situation we have 2 low points. So we have 2 relative minimums. So we're going to say that's like -0.65 and then -1. And then the other one looks like it's at 1.65 and -1. Okay, so it looks like it's going up, up. If it's going up, up, it's even, and my back end thing is going up, so we know it's going to be positive. So the sign is going to be positive. My degree is going to be even, because that talks about the exponent. Okay, it looks like it is going up and then down, so we're going to positive infinity and negative infinity. Looks like it's crossing at -3, 0, and 2. I have a max point right there at 1, 4, and a relative min right there at -2, -8. Okay, so it's going up and then down, so I know that's going to be odd. My back end arrow is going down, so I know it's going to be negative. So the sign is going to be negative. My degree is going to be odd.